We're back with the daily space weather. We've got no less than 6 sunspot groups at the moment on the Earth-facing portion of the solar disk. Also a coronal hole right in the Earth-facing zone. We can expect some solar wind from that in about 4 days. And we can expect a coronal mass ejection impact pretty soon, in about 2 days. Not sure if NOAA's forecasting it or not, but we are. That's the sun from the SDO, by the way, in 171 angstroms. Here's 304 angstroms. Most active region on the sun is this sunspot down here. I'm not going to get hung up on the names, just the physics. And let's take a look at the colorized magnetogram here. Again, 6 sunspot groups at the moment. So here's the latest image. You can see 1, 2, 3, 4, 5, 6 regions that all exhibit ombre. Here's a little closer look. You can see the one in the northern hemisphere there has gained in complexity over the past 24 hours. So a bit of an uptick here in solar activity. Here's the northern hemisphere in 171 angstroms. Some filamentary behavior up here. And you can see 3 sunspot groups rotating in there. Also some coronal holes visible north of that most westerly sunspot group. Here's a southern hemisphere. And we've saved some of the spectacular imagery from the SDO for the end of the video. Looks like some ejecta down here making its way out. And there indeed is a coronal mass ejection on the far side of the sun at the moment. Not on the Earth side. We'll show you that toward the end of the video. The radial flux has popped up to 80 solar flux units. Here's the 1-year chart of the radial flux from solon.info. The black line's the radial flux. The red line is the sunspot number. And we should see that precipitously rise here as well shortly. So there is a period of geomagnetic unrest forecasted here late in the day on the 23rd. I don't think that's the coronal mass ejection impact, but I don't see it modeled either. So when we look at the Space Weather Enthusiast dashboard, we don't see any modeling of the incoming coronal mass ejection for some reason. So let's just move on. And we did see some earthquakes here over the past 24. Here's a 90-day bar graph of seismicity. I like it at a glance to show us what is going on as far as earthquakes. And most of the earthquakes occurred in about a 2-hour period. We'll get to it. So there were some 5 magnitude quakes and there was one 6 magnitude quake. So there's a 5.1 in Chile, a 5.2 in the Kermadec Islands. That one was nearly 400 kilometers depth. A 5.8 at Tonga, and that was just about 2 hours before the largest quake here of the past 24. Also a 5.4 occurring at the Sandwich Islands, and there's that 6.0 at the Kuril Islands, the largest quake of the past 24 hours. South of the Kamchatka Peninsula, the volcanically highly active peninsula of Russia. It's a bit of a desolate spot. And just letting the list scroll here. If we miss anything, let us know in the comments. There's a 5.0 at Tonga. That's at 327 kilometers. And volcanism showing up quite a bit in the news lately because of the La Palma volcano in the Canary Islands. The possibility of a mega tsunami caused by a crustal slip volcanic activity induced tsunami. Some spectacular footage of a new fissure erupting last night, 9 o'clock local time, near the municipality of El Paso. And here's some footage of that. Quite a few buildings right around there where we see some volcanic ash geysers. So the eruption continues to evolve as a new fissure opened. Let's keep an eye on that one. Suminose Jima in the Ryukyu Islands also exploding. 15,000-foot ash plume produced by that volcano. Samisa Pochnoi has lowered the alert level to orange. The Alaska Volcano Observatory. Sangay in Ecuador exploding. 22,000-foot ash plume there. That's an uptick at the Ecuadorian volcano of Sangay. Revenador, 17,000-foot ash plume. I think that's an uptick at Revenador as well. Sabancaya producing continuous ash emissions, reminding us to not pole vault. Please don't pole vault the caldera. Don't pole vault the caldera, folks. We need the views on YouTube. So make sure you press like, press subscribe, etc. And visit the links below the video. Pick up some merch. Perhaps join the Smash team. Head to smashamash.com. Visit our links for social media and so on over there. But most importantly, do not pole vault the caldera. Do join the Smash team. Again, you can find links to all of that stuff below the video. Please support the channel. We need your assistance to remain in existence. Next, looking at magnetic data here, and we see a divergence in the measurements from the GOES 16 and 17. Check it out, the lines crossing here and go in the opposite directions. For you new viewers, the N's and M's stand for midnight and local time. Midnight and noon local time for the satellites. So here the red M represents midnight for the GOES 16. The blue N represents noon for the GOES 17. And Earth is right now in a South Pole-oriented current sheet. So the heliospheric current sheet is polarized to one pole or the other. And there is a bit of a magnetic tug-of-war going on in the Earth-facing zone at the moment because we've got sunspots in both hemispheres, trying to decide which is the dominant current sheet for the earthly portion of the solar system. There's the latest image. As you can see, the Earth at the moment solidly in a South Pole current sheet shown here in red. North Pole in green, South Pole in red. Pardon my bad penmanship. Here's a line of sight view of the same data. It also shows you the solar magnetogram. And here's the coronal hole line of sight plot. You can see that large red-colored South Pole-oriented coronal hole there. There are also some North Pole-oriented coronal holes up here. They're not showing up very well on the computer model. You'll be able to see them in the 193 angstroms view. And here's that. Right up in this area, we see a little bit of coronal hole, there. Those are North Pole-oriented. Down here, a South Pole-oriented coronal hole. We can expect a high-speed wind from that in about 3.5 days. 3 or 4 days, I'll say. That one might be significant here at Earth. It could cause some minor geomagnetic unrest or a geomagnetic storm. So check out all the sunspots. The likelihood of a large flare has gone way up. The most likely place would be out of sunspot 2871, as it is beta-gamma class. And at least 3 of the 6 sunspot groups are currently beta-class sunspot groups. So those much more likely to produce major flares. Solar flare watch in effect as a result of all that. We haven't seen any major flares. We haven't even seen a C-class flare since the 19th. And welcome to the last day of summer, folks. It's the last full day of summer. What are you going to do with your final day of summer? Leave us a comment. Let us know. And here's the GOES proton flux. No spikes in that. No relativistic particles striking Earth recently. Let's take a look at the real-time solar wind next. We've recently seen a little uptick here in the solar wind density and a downtick in the velocity. So density making it up there to 21 protons per cubic centimeter. Velocity making it all the way down to 320 kilometers per second or so. Current conditions are solar wind density 17.8 protons per cubic centimeter, solar wind speed 317 kilometers per second. The rest of the BTBZ, phi angle, and temperature data fairly unremarkable over the past 24 hours. There was a brief moment of a KP3, now back to a KP of 0. The planetary K index is a measurement of global geomagnetism. Let's take a look at geomagnetism in space. It's 4 hours of data. Magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework. If you want to read about that, click on details. There will be a link to the SWMF, the Space Weather Modeling Framework. It's a real MF for that modeling framework. And nothing to write home about here in the past 4 hours. This is more interesting to watch at the onset of geomagnetic storms and so on. Next, we'll look at ground magnetic perturbations, changes to the Earth's B field. Geospace delta B is what that is. And like the last slide, this is 4 hours of data. It refreshed. We're going to let it play through to show where Earth's B field has been changing in the past 4 hours. Whenever you see the word delta or the triangle symbol in the Greek letter delta in science data, it means change in the data. Anyway, that's 4 hours worth. Happy full moon. We hope you're sleeping well. We hope your sleep chamber is very dark, as having complete darkness in your sleep chamber makes a big difference. Just wearing a blindfold doesn't cut it. Your skin has photosensors in it as well. Anyway, here's where stuff is now in the solar system, things like planets. Mars is looking a little lonely over there. Let's advance this 1 week. And there's where things will be in 7 days. Here's a star chart. We've put in the ecliptic, which is the yellow line, and the galactic plane, which is the blue line. Where will you be when Cygnus sets? That's the question that I wonder. Today's cosmology segment, once again, will be integrated into the daily space weather video. Check our playlists for hundreds more cosmology segments. There are over 200 of them in our playlist. YouTube.com/smAsho/playlists. First thing we're going to look at is cosmic rays. Now, cosmic rays are associated with weather, it seems, as the ionization pathways cause things like cloud nucleation to happen. Not a commonly known fact here. Anyway, here are cosmic rays. The past 30 days at Apatity have shown a slight downtick over the past 30. How about Barentsburg? Downtick at Barentsburg as well over the past 30 days. Let's go farther south to Athens, Greece. Here's the Athens neutron monitor, and you can see a downtick there over the past 30 days as well. Perhaps not a surprise to everybody who understands the correlation between sunspots and cosmic ray flux. Here's Mexico City going even farther south. Downtick there at Mexico City as well. Significant downward trend line there. And we'll go back north to go to Oulu. We'll go to Oulu, Finland. There's Oulu, Finland. Downtick at Oulu. And now we'll go very far south to DOMB Antarctica and DOMC Antarctica. Both of those also showing a downward trend in cosmic ray flux. Today we're going to pick a random number, just briefly. It's number 250. And at the Neil Gorell Swift-Bat X-ray Observatory, that coincides with YZCMI, a flare star. Pretty cool. There are the hard X-ray transient outbursts from YZCMI. Let's take a visual of this thing by going to the CDS portal. And here's your flare star in optical. Let's see if we can find some other wavelengths. And here it is on the 2MASS. The infrared survey showing some significant heat coming from that flare star. Now here it is on pan-stars, the optical survey here showing different optical bands. And this is interesting in that the crosshair is not centered on this, so perhaps it is a binary system. I wouldn't be surprised if it were a binary system based on the way that looks. And this one does not show up in ultraviolet light. I don't think the Galax survey included this star, but there's a false color image in X-ray of the flare star YZ-CMI, entry number 250 at the Neil Gorell Swift Bat X-ray Observatory. Go check that out if you like. And today's astronomy picture of the day is from Spain, El Cid. And it's a well thought out image here, a zoomed in filtered image of the sun of 12 days ago when there were so many sunspots on the solar disk, now getting back to high levels of activity again. Is it possible that Sodom and Gomorrah was found? Yeah, well, it turns out a biblical city in the Jordan Valley was likely destroyed by a cosmic impact. We found shock quartz. We found salt deposits all around the area, an indication that perhaps part of the meteorite, if it was a bolide, struck the Dead Sea, salting the land and making it unfarmable for who knows how long. Perhaps this is where the biblical tales of people turning into pillars of salt came from. We're not exactly sure if it's Sodom and Gomorrah or not, but it was a large city, and there was wanton destruction. The apparent output of this was like 1,000 Hiroshimas. Very high pressure and temperature were generated during the event, which happened about 12,800 years ago. Temperatures greater than 2,000 degrees Celsius. Also, spherules showing up. Tiny iron, silica-rich spherules showed up, as did melted metals. It was a bad time for that city. Enough to make it to the Bible and to back into, the book of Genesis, as well as into current scientific studies here. The salt was thrown up due to high impact pressures. It could have been responsible for the so-called late Bronze Age gap, the researchers say, in which cities along the lower Jordan Valley were abandoned, dropping the population from tens of thousands to maybe a few hundred nomads. Nothing could grow in these formerly fertile grounds, forcing people to leave the area for centuries. So fire and brimstone raining down from above. All observations stated in Genesis are consistent with a cosmic airburst, Kenneth said, but there's no scientific proof that this destroyed city is indeed the Sodom of the Old Testament. However, the researchers said the disaster could have generated an oral tradition that may have served as the inspiration for the written account in the book of Genesis, as well as the biblical account of the burning of Jericho in the Old Testament book of Joshua. If you want to read about it yourself, head to SciTech Daily. One of my favorite science publications. Yeah, they even print articles on Sunday, folks. The title is Sodom and Gomorrah, Evidence That a Cosmic Impact Destroyed a Biblical City in the Jordan Valley. That's today's cosmology segment. Again, don't forget to check our other playlists as well. Let's take a look at electrons surrounding Earth. None are currently charging up satellites. Satellites are chilling at the moment. Here's a one-year chart of relativistic electrons from solon.info. Here's your 3-day chart. And electrons are just in a moderate range here as measured by the GOES 16 and GOES 17. Here's the forecast. The green boxes are the forecast. The yellow diamonds are not lucky charms. Those are the observations. And here's a diagram of Earth's Van Allen belts. We're going to show you the total electron content next to show you the most likely spots for GPS errors. And everything's looking fairly normal here and mostly pretty well organized. GPS error is most likely to occur around the equator at noon. Here's another diagram of the atmosphere to show you where the F ionosphere layer is. It's at about 300 kilometers of altitude. And here's your ionogram. Once again, we're seeing some anomalies, and we can expect to see plenty of these around the equinox. The equinoxes are the most geomagnetically active time of year, folks. So in March and September, we see the most activity. And we are seeing some anomalies here, both of the high and low frequency varieties. Here's the latest image. That's 9 o'clock. Here's the anomaly map. This is departure in megahertz from the 30-day median. And you can see those dark blue regions. Those are high frequency anomalies, and the dark red regions are low frequency anomalies. Most of them are around the equator at the moment. A feature of the equinox, which is coming tomorrow, by the way, and we'll be streaming live at the moment of it. It's around 3:20 p.m. tomorrow on Wednesday, September 22nd. Anyway, here's the latest image in the anomaly map from 9 o'clock Universal Time. Check out our meteorology segments if you're only seeing the daily space weather videos. We're about to make one now, and those typically premiere before our daily space weather. Yeah, folks, we do meteorology as well as space weather. Yes, it's all about physics, folks. It's all about physics. Thanks again to our BitChute subscribers. Notice how we get hundreds more views on BitChute per day than on YouTube. I'm sure it's just a mysterious coincidence. I guess the content, maybe the content just sucks, folks. Maybe that's why we're getting such a low number of views on YouTube. I'm sure it's probably because of the lack of quality of the content, right? Also, twitch.tv/smAsho, a reminder. Go follow us over there. They've got a great app. It's the best live streaming platform, in my opinion. Thanks to our YouTube subscribers, etc. If you're new to the channel, please press subscribe and tell your friends and foes about the content. Thanks to our patrons, increasing the probability these videos will continue to exist and remain publicly visible. You're all invited to join the Smash team. And here's a tidbit as to what's going on at the Smash team. So at smAsho.com/Smash team, we've got a subscription services over there to replace Patreon. And we're showing you through the month of Smashtember what it is that we're putting up. All kinds of information that nobody else gets to see. And there are 3 different tiers there. One of them includes a paid-up annual membership, but the 2 basic tiers are $2.99 and $9.99 per month. There's also a bronze level, which is free. smAsho.com/Smash team. You can find links below the video and on our homepage. Welcome to the Neo Renaissance. Congratulations on realizing our channel exists. Here come the rest of our bonus features in the form of the El Teide ground-based solar observatory in Spain. El Teide, Spain, that is. And we do see some filaments up here northwest of this westernmost sunspot. When we did show prep, we saw 6 sunspot groups. Let's see what we've got now. And I only see 2 in the northern hemisphere. So we've maybe back down to 5 here. Quite a few sunspots in the southern hemisphere, though. You can see, let's see, 1, 2, 3. I think there are actually 4 in the southern hemisphere. So we still are at 6 sunspot groups, folks. Here's the latest refresh of the colorized magnetogram. So now it looks like there are 2 sunspot groups in the north and 4 in the south. Eyes on this area over here as well. Keep an eye on it. And when I say eye on, the pun's intentional. Again, there is a coronal mass ejection going on. Let's take a look at the viewpoint from Lagrange point 5, the location of the Stereo A spacecraft, which puts Earth off to your right. And there's a view of that coronal mass ejection. Again, on the far side of the sun, Earth is off in this direction. The left image is the raw coronagraph data. The right image is the difference, which is this just pixels subtracted from previous pixels. So no threat to the Earth there. We'll close things out at 94 angstroms. This is one of the many ionized iron spectra that the SDO takes imagery of. And 94 angstroms is great at showing brightness in active regions like sunspots. It's also great for things like solar flare. So when we see an uptick in solar flare activity, this is one of the wavelengths that we use, as well as 131 angstroms. They take 10 images per minute instead of only 2 images per minute. So here's the northern hemisphere, and we'll close out the video today in the southern hemisphere in this wavelength, as it's the most interesting portion at the moment. This large sunspot down here, the most likely spot to see major flares. And you can see a little bit of crackling of activity there. And it's time to close this thing out. Thanks again for tuning in. Congratulations on realizing our channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted, name and news.